Hey everybody, in this video we are on the unit of exponential and logarithmic functions, focusing on section 2 logarithmic functions, example 5, using inverse properties of logarithms. So something like log base 4 of 4 to the 5th, log base b of b to some power, as well as 6 raised to the power of log base 6 of 9. Same as b raised to the power of log base b of 9. So before we do that, I just want to take a second and look at the examples I have written out on the screen for us already. So what's going on here? What is the cube root of x cubed? Well, I have a composition of a function and its inverse here. Those are going to get rid of each other and I'm left with x. So as long as, the output of the one thing is inside the domain of the other thing, yada yada, all that good stuff, it's all good to go. All right, so sometimes they're not always one-to-one, but I set these up so everything's in a good position for us to go ahead. Sine inverse of x, well, that's just going to be x. What's 1/4 of 4 times x? Multiplying and dividing, those are inverse operations. X minus 5 plus 5, well, that's just going to be x. What if I turned it around and now I raised the cube root of x to the third? Does that make a difference? No, it doesn't make a difference. It's still x in that case. What if I turn this one around over here as well? Does that make a difference? No, it still equals x, right? So when you do a composition of some function and its inverse, you are going to be left with that input, the argument. So what do I have right over here? Well, we have log base b of b to the power of whatever it might be, calling it a big red square. What happens? In this case, log base b and b to the power are gone, and we're left with nothing except the power. You're done. You will always be left with the power. Trust it. You could rewrite it in a different way. I could show you 100 different ways. No need. I'm just going to get right to it. That's the rule. If you want more detail, make a request and I will make you a separate video, but just get the rule down. Now what about the reversal? B raised to whatever the log base b of some input is right there. That's going to be, what's going to happen? Well, the base b and the log base b go away and we're just left with that happy little cloud. That exponent is the only thing that is left. So what do we got over here? Example 5a, log base 4 and 4 are gone, and the answer is 5. Done. 6 and log base 6 are gone, and the answer is 9. That is it. Now sometimes do they get trickier? Yes. That's why I can go into more depth. You could think of this as b to the y, set it equal to x, and rewrite it in log form. And you could think of this as log base b of x, set it equal to y, and rewrite it in exponential form. That's your big fat clue for doing those. So let's just look at the last two examples, which are right over here. So log base 7 of 7 to the 8th power. What does that end up equaling? Well, those are gone, and we're left with 8. Done. 3 and log base 3 are gone. And that will equal 17. And I guess, let me show you, one little spoiler alert. I'll keep it kind of easy. What if it was 9 to the log base 3 of 17? We can't just cross them out, but it is still doable. So I'm going to consider this as b to the y equals x. So I'm going to set this equal to x. And now I'm going to write it in the other form. So that's going to be log base b, which is 9, right, of the what am I doing? Log base b of x, which is just x, equals the power y, which is log base 3 of 17. Now again, I cannot use one-to-one property, just cross everything out, but I can do a bit of a change of base formula. And because I see, actually I could have done that even earlier in another step, but that's okay. I'm just going to do it here. So I can make both of these bases, say, 3. So or I can make them both. Which way should I do it? I make them both 3. Yeah, I'm going to make the bases both 3. I think that's easier, the smaller number. So what will that look like? I'm going to have log base 3 of x, change of base formula, so if you know that already, over log base 3 of 9 equals log base 3 of 17. Now log base 3 of 9, I can evaluate. 3 to what power is 9? 2. So that means my denominator is 2, and I can multiply that 2 to the other side, right? So now I have log base 3 of x equals 2 log base 3 of 17. Now I'm going to take that 2, power property, put that away, so it's now 17 squared. So that means x equals 17 squared, because I'm going to use the one-to-one property to ignore my log base 3's, and 17 squared is whatever the heck it is. 17, 16, 17, I don't know, 10 plus 7 times 10 plus 7. And that is 100 plus 70, 70, 140 plus 49. Oh yeah, 289. I knew that. I don't know. I'm tired. I forgot. So in case you were wondering how you do it in that case, there's an example. Give that some thought. Sorry, this is a mess. Hope that was helpful. If you love the bonus example, thank you much. And you could thank me by telling me a thumbs up or telling me a comment or something. Where's my thumbs up? Oh. Thumbs up. If not, if you hated the bonus, thumbs down. Questions, comments, concerns, requests, and feedback in the comment section. Check the playlist on the screen right now and check the description box for something specific. So that's it for now. Sayonara. Bye.